this video, I'm going to talk about how to solve problem using quadratic model by two examples. The goal is to solve problem that can be modeled by quadratic relation using variety of tools and strategies. Let's get started. So first question is wording problem. And the volunteer at a food bank arranging a concert to raise money, they have to pay a set fee to the musicians, plus additional fee to the concert hall for each person attending the concert. The relation P equals negative n squared plus 580n minus 48,000 to model the profit P in dollars for the concert, where n is number of tickets sold. Question asks you, how can you determine the number of tickets that must be sold to break even and to maximize the profit? Okay, so break even, right, means profit equals 0, right? And maximize the profit means maximum profit. So it's find out y coordinates vertex. So because this the coefficient a, right, equals -1 less than 0, so the parabola should open downward. So that's why this relation P has maximum value, right, for the profit. Okay, let's do it. First, copy the relations. P equals negative n squared plus 580n minus 4880, and factor out -1, so it's negative n squared minus 580n. So I leave 48,000 outside to make simple, and then I create square, right? So in vertex form, n squared minus 580. So sorry, it should be here n, right? So 580n, right, should add half b squared, right? Negative 580 divided by 2 should negative 290. Actually, 290, right? So it's 290 squared. You add, you have to subtract 290 squared, and then bracket minus 48000, and then here is perfect square, right? So n minus 280 squared, and then negative positive, yeah, 290 squared. So here square, what's going on? And then minus 48000. Okay, so copy, and minus 290 squared. This is 84100. I already use calculator determine it. So this 48000. Okay, and n minus 290 square plus, and 84100 minus 48000 equals 36100. Okay, this is the vertex form, right? So it's vertex 290 and 36,100. Okay, so the volunteer have to sell 290 tickets to earn maximum profit, right? This max profit $36,100, right? As you know, this in less than 0 open downward, so its maximum profit should be 36100, right? So good. Oh, let's determine the number of tickets that must be sold to break even. So in order to break even, so that P equals 0, right? And P equals 0, it means, and we use the vertex form, make it easy, right? N minus 290 squared, right, plus 36100 equals 0, right? Okay, both sides multiply by -1, and then, okay, so let's go one step by step. N minus 290 squared minus 36100 equals 0, and I moved this number to right, and minus 290 squared equals 36,100. Okay, both sides take square root, and minus 290 equals, right, we have to have positive negative, right, 36100. So you know what, this I used the calculator already, that is 190. So n minus 290 equals positive negative 190. Okay, so n minus 290 equals either 190 or this positive. N minus 290 equals negative, right? So this one is 208. Okay, n equals 480, right? This n equals 100. So it's two solutions, right? 480, right? It's a 480. 480 is 100. So it's two solutions. It means two zeros. So the number of tickets must be sold to break even. So one is 480, other one is 100. So that's the answer. Okay, let's go to next. Yeah, let's look at the questions. Statisticians use various models to make a prediction about population growth. Ontario population in 100,000 can be modeled by the relation P equals 0.007 s squared plus 0.196 plus 21.5, where x is number of years since 1900. The question A, using this model, what was Ontario population in 1925? B, when will Ontario population reach 50 millions? Okay, so this is the relation between population and the number of years. So look at the graph. This is Ontario population since 1900. X-axis represents number of years since 1900, and Y-axis represents population in 100,000. Here, this start here is 1900. Look like the population 100,000. Okay, let's do it. So first, solve A, using model, what was Ontario relation in 1925, right? So 1925, that's the year, and start 1900. So it's how many years? So 1925 minus 1900 equals 25 years. So x equals 25 years. Okay, let's P copy the relations. 0.007 s squared plus 1.196x plus 21.5. So we substitute 25 into the relations. 0.007 times 25 squared plus 0.196 times 25 plus 21.5. Okay, I already use calculator to determine the value is 30.775. Remember, this is unit in 100,000, right? 100,000 we have to multiply 100,000. So population should be 30.775 times 100,000 equals 307,750. This is the population in 25 years. That is 1925, right? Okay, this is A and B. When will Ontario population reach 50 million? 50 million, right? 50 million, okay. 50 million means here, and then the units is P should be unit 100,000. So, okay, should be, okay, 50, right? So the P equals 150. So let P equals 150. So P 150 should equal 0.007 s squared plus 0.196x plus 21.5. Okay, both sides minus 150 should be 0 equals 0.007 s squared plus 0.196 and plus 21 minus 150. So we continue 0.07 s squared plus 1.96, and so I already used calculator. That is negative. Oh, should be negative, right? So let's remove it, erase it. Okay, because it's 150, right? 150 is negative, so it should be negative. Negative 128.5. Okay, so these equations we use quadratic formula, right? Remember? So let's determine A, right? A equals 0.007, B equals 0.196, and C equals negative 128.5, right? So we substitute. So first, let's copy the quadratic formula to remember negative b plus minus b squared minus 4ac divided by 2a, right? We substitute negative b is negative 1.96 plus and b squared, right? 0.196 squared minus 4 minus 0.07 times negative 180.5 squared, right? Okay, divided by 2 times 0.007. Okay, I already use calculator. So x1 equals negative 150.2, and next is x equals 120.2. Okay, so negative does not make sense, right? So we take 122.2. So the answer is 120.22. So it's reach 15 millions. 122. You have to plus that's the years, right? Number of years. So 1900 plus 120. We take 120. That should be equals 2022, right? So which means in order to reach 50 million, the people's 50 millions, so that year should be 2020. Yeah. So okay, that's it. Thank you for watching.